All right, welcome to part 2 of lesson 9. We're on page 78. I would like you to hit pause right now and try to do this page, these 3 problems. And if you look at them and say, no clue, that's all right. Come back, watch it. I'm going to explain all 3 of them. But if you have a good idea of how to do it, that's great, and that's a good way to start. So, hit pause and try them yourself, then come back and watch them. All right, so here in 15, you'll notice that we have weights. So I'm going to go ahead and create my own little table here of lab, quizzes, I've got the midterm, and I've got the final. So now I'm going to put the weights in red. So it says lab reports are 20%, right? They tell me that up in here. Quizzes are 20%. Midterm is 30. Okay, this is really, really nasty. So 20, 20, 30, and 30, right? Those are my weights. Now the scores, I'll put those here in blue, go in this last column. Well, the midterm and the final are pretty easy because we only have one value. But the other ones, we have multiple. How do I figure out what to put in the scores column? What did you say? What? Did I hear you right? You are correct. You find the average. So for the lab reports, those 5 values, we add them together and divide by 5. Hopefully, when you find that, you found that the average for the labs were 77. And when you added the 4 quizzes, you got 78.5. So, and if I'm wrong, forgive me. But that's what I got when I calculated. So I have my scores. So when we're using the weight method, right, we then take the weight times the score. So the lab, you've earned 15.4 points. For quizzes, 15.7, 22.8 for the midterm, and 16.2 for the final. So to find your final grade in this class, we will take these 4 values here in the last column, add them together, and this lucky person ends up with a 70.1 or a C in this class. And that's pretty good, right? So if you have more than one value, make sure you find the average first for the score column. All right, let's move on to number 16. I typed this one in. It's the same problem in your packet. I just didn't like the picture. So a new local cafe wants to advertise an average price for their meal. Help them figure out an average if they sold 60 $5 tacos, 32 $7 sandwiches, and 24 $8 mixed salads on any given day. So we got to find the weighted average based on price. So I've got 60 tacos at $5 a piece. I've got 32 sandwiches at $7 a piece. And I've got 24 mixed salads at $8 a piece. So I know total I sold 116 items. So when we're figuring this out, we want to do the total cost over the total number of items sold. And I know my total number of items is 116, but now I've got to figure my total cost. So I'm going to make a third column, and I don't want it to be red. I want it to be blue. And I'm going to multiply. If I sold 60 tacos and they were $5 a piece, right, I had $300 worth of tacos. And if I sold 32 $7 sandwiches, that's $224 worth of sandwiches. And if I sold 24 salads at $8 a piece, that's $192 in tacos, or in salads. So I took in $716 total in 116 items. So when I go back to my average, I've got 716 over 116, which equals $6.17. And that would be my total, or my average price for a given day. Okay, which kind of makes sense. I sold the most tacos, so it should lean towards the taco price because that's where all my data is. All right, let's look at number 17 there on page 78. So you could do this 2 ways, and it tells you to try both methods, but I'm going to be honest with you. If I don't have percentages given to me, I don't use the percentage method. I say, okay, I have 10 scores total, right? So I'm going to do total scores divided by number of scores. So I know that my denominator is going to be 10 because I have 10 scores. So I need to find my total. I multiply across. 100 times 1 is 100. 90 times 4 is 360. and 80 times 5 is 400. So my total scores is 860. If I take 860 and divide it by 10, my average score is an 86. And that makes sense. The majority of my scores are between 80 and 90, so my average should probably be between 80 and 90. All right, you're trying to figure out your average score here. All right, so I hope that makes sense. If it doesn't, let me know. I can get you a couple more different examples of these to try. All right, so this is kind of a little extra piece here in the slugging percentage. We're going to talk about Hank Aaron together, and then I'm going to ask you to fill out the rest of the table on your own. So, to find the slugging percentage, you will see this super fly fabulous, what's it called? It's a formula, up top. So for a single, they get times 1, a double times 2, triple times 3, and a home run times 4. That should make sense because that's how many bases you get, right? Home run, you cover 4 bases, all 4. Triple, you only get 3. And we're going to divide by the total at-bats, and you will see the at-bats over here. Well, the first thing we need to do in this table is figure out how many singles we have. So, let's go ahead and get rid of all of our color, and now we can find our singles. So, to find, in case you're not a baseball person, and I can't believe you're not, but I'll forgive you today. So, hits make up singles plus doubles plus triples plus home runs. All those added together will give you hits. So we've got to kind of work backwards. We're going to take our hits, 3771, subtract the doubles, subtract the triples, subtract the home runs, and that will tell us how many singles we have. So if you take Hank's 3,771 hits, minus 624, minus 98, minus 755, excuse me, you should get 2,294 singles. All right, so hopefully you do. Now, once you do that, we are ready to do the formula. So I'm going to take the singles and I'm going to multiply by 1. Doubles I'm going to multiply by 2. Triples I'm going to multiply by 3. Home runs I'm going to multiply by 4. And when you add those numbers together for Hank, you should get 6,856. We are going to divide that by his at-bats, so 12,364. And when you divide that, you should get 0.555. So his slugging percentage is 0.555, right, which is super fly fabulous. So I'd like you right now, go ahead and hit pause, find the singles for the rest of the people and their slugging percentage based off that of what we just did for Hank. Okay, so I've got the rest of these values plugged in, and I did forget my calculator at work, so I'm doing these with my cell phone calculator. So if I made a mistake, will somebody please shoot me an email and let me know so I can fix it in here, which will really suck, but I'll do it because, you know, you guys are fantastic. So this is what I came up with number of singles for every person and their slugging percent. There we go. Sorry about that. I had to fix Wade Boggs' slugging percentage because that 3 was looking a little rough. So check those, see if they work for you, and if they don't, you know, where did your mistake come from? When you added them together for each one, Joe Jackson, you should have gotten, the numerator should have been 2577. For Wade, it should have been 4064. For Tom, 276. And for the great Yogi, it should have been 3643. So those have been your numerators, and then you would have divided those by the number of at-bats in order to find your slugging percentage. So when we look at the questions at the bottom, we already did part A. Who has the best slugging percentage, or the best slugging average? You know, that would be the great Hank Aaron. And does the slugging average always go up with the number of at-bats? Well, look at this. So we have Wade Boggs with 9,000 at-bats, and he's got a slugging percentage of .443. But Shoeless Joe only had about 5,000 at-bats, and his slugging percentage was higher. So, no, the slugging average has nothing to do with the more at-bats, the higher your slugging percentage. It has to do with how many home runs, how many triples, those kind of things. The more extra base hits you have, the higher your slugging percentage. So you've got to make sure that you're paying attention to those kind of things. All right, last page of this video deals with decibels and these workers. So if you look, I don't have it in this this picture, but above this on page 80, we're on page 80, you see that it says OSHA allows 8 hours of exposure to 90 decibels and only 2 hours of decibels of 100 or more. So when you're looking at these, you notice that none of them have more than 2 hours at 100. But when you think about an 8-hour workday, are any of these guys above that? So we're going to calculate weighted average for each one of these workers to see if they're within the OSHA guidelines. So worker number 1, he worked, or she, worked 3 hours at 95 decibels and 5 hours at 80 decibels. So that top number will give me total decibels, and we're going to divide it by how many hours we were there. Right? So when I figure that out, 3 times 95 plus 5 times 80, divide that whole answer by 8, worker 1 has an average decibel for that day of 85.625. Well, that's below 90, so that worker is within OSHA guidelines. That worker, thumbs up, you're golden. Worker number 2, 2 hours at 105, 2 hours at 85, and 4 hours at 87. So in those pieces, that worker falls within, but let's find out about the average for the day. So when you add those up in the top and divide by 8, this worker has an average decibel for that workday of 91. That is above the OSHA guidelines of 8 hours of 90. So that person needs to have some maybe quieter time at work, is what it looks like. Okay, so that is a big does not meet OSHA guidelines. Let's look at worker number 3. 3 hours at a decibel of 78, 2 hours at decibels of 100, and 3 hours at decibels of 92. So, 5 hours above 90 is a lot, but we're still looking at overall, right? Fits within the 2 hours over 100 is fine. And then we have to look at the 8-hour average. So the 8-hour average for this worker is 88.75. Close to 90, but not above, and therefore this worker is okay within OSHA guidelines. So only worker number 2 is violating OSHA guidelines. And that is video number 2 for lesson 9.